Hello learners, in this video we'll learn about what are vector embeddings, its use cases and which databases to use on Google Cloud to store these vector embeddings. So let's start it. Okay, so before we move forward, let's understand what are vector embeddings. Vector embeddings in machine learning are like 3D maps grouping similar items close together in a multi-dimensional space, similar to how we how we use maps to understand our world. So in Google Cloud Platform's world of machine learning, these things could be anything like words in a language or items in a store or images. Okay. So to put it in a context, imagine a map where all the pizza places are close together and all the burger places are also in another cluster. But pizza places and burger places join, these joints are actually far apart from each other. That's what vector embeddings do for data. This similarity mappings helps systems predict patterns and provide accurate recommendations. It's a user-friendly tool needing no extensive data science expertise, simplifying complex tasks and guiding predictions efficiently. Now let's move next and then figure out what are the use cases of vector embeddings. Right. So now here, if you can see in this screen, there are multiple use cases that we can talk about vector embeddings. So the very first one is recommendation systems. Vector embeddings help services like Netflix or Amazon to suggest what you might like. Now coming to the Google search engine, so they enhance searches from googling phrases to finding image origins. The next one is Google Chat. So again, Google Chats use these embeddings to understand and respond to your queries. Again, data pre-processing, they prepare data for use in machine learning methods. Now, looking at one-shot or zero-shot learning, so here, even if you have very small amount of data, you can use the vector embeddings to learn from this small data and even enhance your prediction models. The other use cases can be fraud detection, typo detection. So typo detection is nothing but it's like embeddings that assist in finding what you need, even if there is a typo mistake in your uh, sentence. The next one could be the drift detection. So they identify when machine learning models lose accuracy and then try to and that helps to fix it quickly. And there are many more applications of vector embeddings in machine learning, which are wide ranging and continually growing. Okay, so now we have understood what is vector embeddings, what are its use cases. Now let's see how these vector embeddings are created. So I try to summarize it a bit. Let's see how it is created. So vector embeddings can be created using pre-trained models or by developing your own models. Now this can be developed using specific algorithms. So these algorithms actually help you transform the complicated data into a map with multiple layers or dimensions to deal with, like in case of natural language processing. So to deal with words, there are programs like Word2Vec. So they read through lots of text to grasp how words are used. Now these words are often used, those words which are often used in a same way they are placed together on the map. Now, this conversion makes abstract or hard to handle data straightforward and number based. So, other computer programs can easily analyze it. Now, that's all about on high level how these vector embeddings are created. Now, let's move next and figure out what are the vector embedding databases available on Google Cloud. So as you can see on this particular presentation, so vector databases in GCP, there are 3 vector databases that we can consider with the recent updates for the recent upgrades happened for LODB and even for CloudSQL as well. So by default in GCP, matching engine is what we use for a vector database. We can also use CloudSQL on PostgreSQL. That's another PG. I mean, using the PG vector, we can use that. Also, there is one for the LODB. So again, it's again based on the PostgreSQL database on LODB, which can be used as a vector database. So there are various advantages and some of the disadvantages as well of using either of these databases. Now let's see that. So, so if you can see in this particular table, there are several features which are very similar, and obviously they are beneficial. However, there are some key differences between them. So matching engine, if we take a matching engine, so in case of matching engine, it's a specialized vector database that is optimized for ANN search, which is also called approximate nearest neighbor search. On the other hand, CloudSQL for PostgreSQL is a general purpose database that can be used to store and query vector data. And talking about the LODB, it's a new generation of PostgreSQL that is designed to be more scalable and performant than compared to traditional CloudSQL, Postgres on CloudSQL. The best vector database for you will depend on your specific needs and requirements. So now let's move next. So I try to capture most of the references which can be useful to understand and get even better insights of these vector databases. And also I have given a breakup of costing for all of these databases on GCP. So to summarize, vector embeddings cluster similar items in a multidimensional space for machine learning. They enhance predictions, searches, and have broad applications like fraud detection. Algorithms such as word-to-vec simplify data for computer analysis. Databases like Matching Engine, CloudSQL for PostgreSQL, and LODB cater to vector data needs. So that's all for this short video. Thanks for watching. Please like and subscribe to my YouTube channel to learn more about Google Cloud.